Hello and welcome to Sleepy Science Story. This is your time to slow down, to let the edges of the day soften, to let your thoughts quiet like leaves settling after a breeze. Tonight, we're going to drift together into one of the most mysterious, most universal experiences of all, death. But don't worry, this isn't a grim tale. It's not sharp or sorrowful. It's a quiet science story, a soft unraveling of what we know, what we wonder, and what gently happens to the body, the brain, and even the atoms that make us when life begins to fade. Because the truth is, death is not one single moment. It's a process, a passage, a transformation that happens slowly, quietly, sometimes even beautifully. And the more we study it through biology, chemistry, physics, even astronomy, the more we see death is not the opposite of life. It's a part of it. So settle in, let the world outside go dim, let your breath find its rhythm. And as we begin this peaceful journey, I do hope it isn't too interesting. But if it keeps your mind glowing just a little longer, at least it will be glowing with gentle wonder. Let's begin where all endings begin, with a breath. Not the dramatic kind, not the gasp of fiction or the echoing cry of farewell, but a quiet, simple inhale, just one more breath, and then none. The space between 1 and 0 is where death begins. For most of us, it will be this soft. The final breath, that subtle moment, often arrives without fanfare. It is not loud, it is not cruel. It is simply the end of a rhythm that has carried us for years without asking for thanks. The average human will breathe around 700 million times in a lifetime, an unceasing tide of air flowing in and out, day and night, in sleep and speech and stillness. And then, at some point, the tide recedes for the last time. The lungs pause, the muscles rest, the body stops its quiet, diligent work. But this is not an instant shutting off. Death is more like a dimming. When we speak of the moment of death, what we really mean is a span of time where one system fails, then another, and then another, in a choreography as slow and delicate as a lullaby. When the breath leaves, the heart is often next. Without oxygen-rich blood, it slows and finally stops. Yet even then, silence isn't immediate. Some cells continue. The body does not vanish. It simply begins its return. At first, the lack of oxygen is felt in the brain. Neurons flicker, signaling fading into static. But recent research has shown something remarkable. In some people, moments after the heart stops and breath has ceased, the brain produces a small, synchronized burst of electrical activity, a final ripple of light behind the eyes. No one knows exactly what it island. It might be the brain processing its own ending, or a flood of neurochemicals releasing in a final cascade. It might be nothing more than a final flicker. Or perhaps it is something more mysterious. The truth is, we do not know, and in that not knowing, there is wonder. It is here, in the breath between life and death, that time begins to stretch. For the one who has died, the world has already gone quiet, but for the body they leave behind, the process continues. Skin cells continue to divide. Hair follicles may respond to the absence of signals. Certain organs remain transplantable for a short while. Death is not one door closing, but a corridor gently dimming. It is less like falling off a cliff, and more like wading into a still pond, where each ripple of motion becomes smaller until everything is still. There is a peace in this, a kind of scientific poetry. Because even in that final moment, the body does not panic. It softens, it releases, it returns. One breath, then none. And then, in that silence, something new begins. Not life, perhaps, but transformation. The same atoms, still held together, still humming faintly, death, it turns out, is not the end of movement. It is the beginning of a new kind. When the heart stops, it does so with remarkable quiet. There is no crashing final beat, no dramatic crescendo, only a soft withdrawal from rhythm. The pulse that once pushed life through every corner of the body slows, weakens, and fades, like a tide that forgets to return. For so long it has worked in silence, tucked behind bone and breath, beating without applause. And when it ceases, the world does not tremble. The stillness simply settles in. The heart's final moments are not as sudden as we might imagine. Circulation tapers rather than halts, particularly in the smallest vessels. Some areas continue to receive blood for a short while. Cells that depend on oxygen begin to respond quickly, but not all at once. The organs closest to the center, the brain, the liver, the kidneys feel it first. Muscles relax, blood pressure vanishes. A gentle collapse begins within the body's complex orchestra, each instrument lowering its volume one by one. Even as the main pump has gone quiet, the body still holds warmth. There is no immediate cold. The skin, especially at the core, retains heat for a surprising length of time. In hospitals, where the moment of death is measured by instruments, it is not unusual to find a pulse long vanished, but a body still soft and warm to the touch. To those who sit nearby, to those holding a hand or brushing a strand of hair, it may not yet feel like absence. That warmth is a lingering kindness, a final echo of life. Meanwhile, gravity begins its quiet work. Blood, no longer moving, begins to settle in the lower parts of the body. This is called livor mortis, and it paints the skin with gentle purples and blues, like watercolor blooming on paper. It is a slow redistribution, not a breakdown, and it offers one of the first visible signs that the heart has ended its work. It happens gradually. The body does not rush into stillness. It leans into it. The cessation of the heart is also the beginning of chemical change. Oxygen, which once sustained the body's energy, is no longer being delivered. Without it, cells shift into an anaerobic state, one less efficient and more chaotic. Acids build up, and the body's delicate balance of pH begins to shift. But this too is not abrupt. It is the biology of falling asleep, not the chemistry of disaster. To the mind, the heart's silence means little once consciousness has gone. If the final breath is the exhale that opens the door, then the final beat is the closing of the gate behind it. There is no pain in this. No sudden sensation, just a release from the need to continue. That is what the heart ultimately does in death. It stops needing. No more pressure, no more pulse, no more insistence on movement. What remains is stillness, and in that stillness, the body begins the most natural process of all. It begins to rest, fully, finally, completely. In the quiet moments after the heart and lungs have let go, the brain lingers. It does not vanish instantly into silence. Instead, it dims gradually, like the slow fading of a lantern that has burned through its oil. Though it is one of the most sensitive organs in the body, it is also one of the last to surrender. Within that fragile space between breath and stillness, something remarkable can happen. A final flicker, a burst of organized activity, a gentle flare behind the eyes, even after the rest has stopped. Researchers have recorded this phenomenon in both humans and animals. After clinical death, when the heart no longer beats and the breath has ceased, there are sometimes brief and unexpected surges of electrical activity within the brain. These are not random, static. They are structured, rhythmic, and often concentrated in regions associated with consciousness, memory, and perception. For a moment, the brain seems to brighten, not outwardly, not in behavior, but in signal, as if the mind is quietly tidying its thoughts, wrapping up its story. No one is quite sure what this means. Some scientists suggest it is the brain's way of responding to the loss of oxygen, a kind of final flurry before systems shut down. Others wonder if it is more than that. Could this be the biological foundation of the near-death experiences described by so many? The vivid visions of tunnels, of light, of floating above one's own body? These stories, told across cultures and centuries, often arrive from those who have returned from the edge. Their accounts vary, but many describe a feeling of calm, of peace, of beauty. From a physiological point of view, the brain at the end of life is not only losing oxygen, it is also bathed in a wash of chemicals. Neurotransmitters like serotonin and dopamine may flood the system. Endorphins rise. The brain, no longer tasked with holding itself together, may enter a state of release. It is not unlike dreaming, perhaps even more vivid. There are theories that this release of chemicals creates a hallucinatory experience, shaped by memories, beliefs, or deeply embedded neural patterns. The mind, untethered from the constraints of survival, may simply open like a flower. But beyond theories and instruments, the simple truth remains. The brain does not go quietly. It whispers. It glows. It folds gently inward, and in that final folding, it may offer a kind of grace. Whatever else it is, death is not the moment when the brain breaks. It is the moment when the brain lets go. In the end, we are not conscious of our unconsciousness. We do not feel the last neuron fall quiet. We do not hear the final whisper of electricity as it fades into stillness. But it is there, brief and soft. The last expression of something that spent a lifetime wondering. The brain, ever curious, ends not with an answer, but with the gentle closing of a question, a flicker, a pause, then peace. For most of human history, death was understood as a single moment. A person was alive, and then they were not. The transition seemed sharp and final, like a door suddenly shut. But modern science tells a more layered story. Death, it turns out, is not a switch. It is a sequence, a process, a slow unfolding of changes, like the dimming of the evening sky where light does not disappear all at once, but fades gently, shade by shade. Even in medical settings, there is no single definition of death that fits all purposes. There is clinical death, when breathing and heartbeat stop. There is biological death, when the cells and tissues of the body begin to break down beyond repair. And there is brain death, which refers to the complete and irreversible cessation of brain activity. These moments may occur within minutes of each other, or they may be stretched out across hours. Death, in this sense, is not one moment. It is many, nested inside one another. The body does not give up all at once. The lungs may cease their rhythm, the heart may fall still, but deep within, certain cells continue on. Skin cells divide for a time, muscle cells hold a charge. Even after a person is declared dead, there is still activity in pockets and corners, like embers smouldering after the flame has gone. This continued function is not survival. It is the last echo of life. A brief holding on, not because the body resists death, but because it does not rush toward it. Different tissues and organs decline at different rates. The brain, hungry for oxygen, begins to shut down within minutes. The kidneys and liver follow a little later. Skin and bone take longer still. In organ donation, this timing is crucial. Surgeons can remove and preserve certain organs hours after death, while others must be taken within minutes to remain viable. Even in silence, the body follows a schedule. What this reveals is that death is not a cliff. It is more like a shoreline, a place where water and land meet and shift and exchange. Standing at that threshold, the distinction between life and death becomes less precise than we once believed. The breath has gone, but warmth remains. The pulse has vanished, but cells still flicker with energy. It is a borderland, a place where endings and beginnings mingle in quiet negotiation. This slow departure can be seen as unsettling or as comforting. It depends on how one chooses to look, but there is a certain gentleness in it. Nature does not demand abrupt exits. It allows space for the body to retreat, to transition, to fall into stillness in its own time. Nothing hurries. The body unwinds like a clock that does not stop but slows, its ticks growing further apart until there is only silence. So when we speak of death, we are not speaking of a moment frozen in time. We are speaking of a process, slow and ancient, shaped by biology and softened by its very slowness. A patient ending that takes its time. There is a quiet magic to what happens after we die, not in the mythical sense, but in the deeply biological one. The body, so long occupied with motion and maintenance, begins a different journey. A slow return, a giving back. And while the idea of decomposition might stir discomfort in the waking mind, within the soft hush of science, it reveals itself as something gentle and essential. It is the final collaboration between the body and the natural world, one that unfolds not with violence, but with remarkable care. The first stages of this process begin not with outside forces, but with the body itself. Without oxygen, the delicate balance of chemistry begins to shift. Carbon dioxide builds. The pH inside cells drops. Enzymes that were once carefully regulated are now free to act without instruction. These are the very enzymes that helped you digest food in life. And now, with no more meals to process, they turn inward. They begin to break down the cells that once held them. This is not an attack. It is more like unlocking a final door. The body, in a way, is quietly digesting itself. Not long after, the microbes arrive in earnest. Of course, they were already there. For the moment you were born, trillions of bacteria have lived on and inside you, especially in the gut. They helped you digest, protected you from illness, and played countless roles in your daily survival. But after death, their roles shift. Without immune defenses to hold them in check, they begin to spread. It is not a hostile takeover, it is a final performance, a grand and slow unwinding. These bacteria are the first external participants in decomposition, and their work is foundational. As time passes, this microbial symphony continues, releasing gases and acids that gently change the body's composition. These changes are not chaotic. They follow patterns, rhythms, almost like a biological clock counting backward. The smells associated with decomposition, the softening of tissues, even the gradual drying of the skin, all follow this deeply coordinated sequence. It is nature remembering what to do, as it always has. Eventually, insects may arrive depending on the environment. Small creatures drawn by scent participating in their ancient role as recyclers. Fungi, too, may begin to bloom, especially in the soil. Mycelium threads spread like lace, connecting the body to the earth below. These quiet organisms do not rush. They work slowly, steadily, as if tucking the body in beneath the layers of time. And when the soft structures have faded, when the tissues have yielded to soil and breath and light, the harder parts remain. Bones, full of minerals, linger like footprints. They may last years, decades, even centuries, but even they in time will return. Rain and roots and stone will take them back. Decomposition is not destruction, it is transformation, a natural, necessary part of the cycle that has no cruelty in it, only change. It is the story of everything finding its way home. And in that, There is a quiet kind of peace. Long before we take our last breath, our bodies are already telling a story of change. Each part of us, from the calcium in our anime, bones to the iron in our blood, has travelled an almost impossible distance to be here. We are not made of anything new. We are a collection of borrowed elements, passed down through stars, oceans, plants, and creatures that lived long before us. In death, those elements are not lost. They are simply released, like water returning to the sea. What once formed a person becomes part of something else. This is the quiet science of recycling, carried out not in machines or factories, but in the very soil beneath our feet. Consider the carbon in your body. It once existed in the breath of trees, in the crust of the earth, in the hearts of long-dead stars. The nitrogen that knits together your proteins may have once passed through the roots of a flower or the wings of a bird. In death, these atoms begin a new journey. They do not disappear. They are not destroyed. They are shared. Slowly, gently, the body gives itself away. If the body is buried in the ground, the soil becomes a kind of host. Microbes and fungi break down the soft tissues, releasing nutrients into the earth. Worms and insects carry those nutrients deeper, spreading them into nearby roots. A tree may stretch toward the sky with the help of phosphorus that once lived in a human cell. A wildflower might bloom, fed by the calcium from a rib or a knuckle. In the quiet way of nature, nothing is wasted. Even in cremation, where fire rapidly reduces the body to ash and bone, the transformation continues. The minerals in the ashes, though different in structure, are still made of the same elements. Some families scatter them into rivers or oceans, where they dissolve and travel. Others bury them, plant them, or mix them into soil that feeds new life. No matter the path, the materials go on. They find their way back into the cycle. Our bones, rich in calcium and phosphate, take longer to return, but return they do. Over decades and centuries, even they begin to soften. Wind and rain wear them down, tree roots wrap around them, soil draws their nutrients. Eventually, they fade into the ground, indistinguishable from the world that made them. This constant recycling is not only natural, it is essential. Life depends on death to continue. Every blade of grass, every spoonful of soil, every gust of air contains atoms that once belonged to someone or something else. This is not something to fear. It is something to marvel at. In a way, we are all immortal, not in consciousness, but in substance. The end of a life is simply a pause in the story of matter. So when we think about what happens after death, we can think not just of endings, but of continuation. The atoms go on, they find new forms, they become the ground, the tree, the breeze. And in that soft dispersal, we remain part of the world we leave behind. All throughout your life, you have been sharing your body with an invisible, microscopic world. Trillions of tiny organisms live in and on you, making up what scientists call the human microbiome. These bacteria, fungi, and other microbes are not intruders. They are residents, companions. They help digest your food, support your immune system, and even shape your mood. You are not a single being, but a community, moving through the world as one. After death, that community does not disappear. In fact, for a time, it flourishes. Without the usual systems of the immune response to keep it in balance, the microbiome begins to change. The body, no longer guarded, becomes a landscape of opportunity for the microbes that once served it. This shift is not chaotic. It is organized in its own quiet way, like a forest responding to a season's change. The gut, in particular, becomes a center of activity. It is already one of the most densely populated places in the human body, filled with bacteria that specialize in breaking down the food you eat. But after the last meal is digested and the final breath has passed, these bacteria turn their attention inward. They begin to break down the lining of the intestine itself, not as an attack, but as a continuation of the work they have always done. It is simply that their direction has shifted. As time goes on, this microbial activity spreads. The bacteria travel through tissues and into other organs, carried not by blood flow, which has stopped, but by the slow diffusion through softening membranes. It is a quiet process, unfolding over hours and days. It does not rush. It follows patterns that have been observed again and again, in study after study. Different bacteria appear at different times, forming what scientists now call the Thanatomic microbiome, a community that only comes to life in death. What is perhaps most fascinating is that this microbial transformation is so consistent that scientists can sometimes estimate a time of death by studying which bacteria are active in a body. Each species has its own schedule, its own rhythm, like tiny timekeepers moving to an ancient clock. Eventually, external microbes join in. Those from the environment, from soil or air or nearby organisms, find their way to the body and continue the work of transformation. But the earliest moments belong mostly to the ones that were already there, those quiet passengers who rode with you from birth to the very end. It is strange to think of death as a blooming, but in microbial terms that is exactly what happens. A blossoming of life inside the stillness. A final performance by the tiniest of actors. It is not a story of invasion or decay. It is a story of continuation, of the world's smallest inhabitants taking one last turn in the life they helped sustain. Even in death, you are never truly alone. You are surrounded, supported, transformed not by force but by familiarity. The microbiome gives you a last gift, carrying your body gently into its next form, just as it helped carry you through your very first days. There is a quiet kind of stubbornness in the body after death, while breath has stopped and the heart no longer beats. Some parts of you linger a little longer. Cells, after all, are not coordinated by a single switch. Each one operates with its own tiny sense of time, and in those early hours after life has ended, many of them keep going, as if they haven't quite received the news. Skin cells are among the most persistent. Even after the heart stops, these cells continue to divide for hours. They do not need much to carry on, just a bit of chemical energy left in their microscopic engines. Under the surface, hair follicles and nail beds hold on as well. In some cases, this continued cellular activity creates the illusion that hair or nails are still growing after death. But in truth, it is not growth. It is dehydration, a shrinking of the skin that makes what remains appear more prominent. Still, the cells inside continue their quiet routines, unaware that the system supporting them has let go. White blood cells, trained to seek out threats and heal the body, can remain active for a surprising amount of time. In organ donors, this is especially clear. Even after death has been declared, certain immune functions still respond, still attempt to preserve tissues. It is as if the body wants to protect itself, even as the larger structures begin to break down. In the brain, the most oxygen-dependent organ, cells begin to die off quickly, but not all at once. Some areas fade fast, others last longer, depending on their function and their location. In rare cases, researchers have observed genes turning on after death. Not all of them, and not for long, but enough to raise questions. It is as if the body, even in its final stillness, has instructions waiting to be followed, blueprints ready to be read one last time. This lingering life is not a refusal to die. It is simply biology unfolding at its own pace. Death happens in layers, not in a single fall. The systems that sustained you shut down first, but the individual pieces take time to catch up. It is like a city after the lights go out. Some windows still flicker, some streets still hum. The silence builds slowly. Scientists have come to understand this gradual shutdown through close observation, often in studies of tissue preservation or organ transplants. What they have found is that the body does not vanish into death. It eases into it, like a symphony that ends not with a crash, but with a note held softly until it fades. There is something comforting in this. The idea that the body does not disappear in a moment, but instead unwinds gently. That even after the story has ended, a few lines remain, written in the language of cells. Life, even in its last chapters, is slow to stop turning the page. After death, the body begins to cool. This process is gentle, gradual, and surprisingly consistent. It is called algor mortis, and though the name may sound clinical, the sensation it describes is almost poetic. The warmth that once radiated from within slowly releases into the surrounding air. The body, no longer generating heat through movement and metabolism, begins to match the temperature of its environment, as if becoming one with the room, the earth, or the breeze. This cooling does not happen all at once. It begins at the surface, where the skin is closest to the air. The hands and feet grow cool first, then the arms and legs, then the center of the body. Internal organs take much longer. The heart and liver, wrapped in layers of tissue, hold their warmth for hours. The entire body may not reach room temperature until a full day has passed, depending on where it rests. A warm room slows the cooling. A cold environment hastens it. But always, the pattern unfolds with the same steady rhythm. The rate of cooling has even become a tool. Forensic scientists often use it to estimate the time of death. By measuring the body's current temperature and comparing it to its expected rate of decline, they can calculate how long it has been since life slipped away. It is not a perfect science, as many variables can affect the result, but the principle remains sound. The body, left to nature, follows its own gentle timeline. This cooling is not harsh. It is not immediate. It is a gradual letting go. Imagine standing outside as the sun sets and the warmth of the day slowly fades from your skin. That is how the body cools. Not in shock, but in surrender. There is no alarm, no urgency, just the quiet passing of heat from one place to another. Inside, the cells no longer produce energy, muscles no longer burn fuel. The tiny generators that once kept the body in motion fall silent, and without them, warmth cannot be sustained. But for a while, the body remembers. It holds its heat the way a stone holds the sun's warmth into the evening, radiating a little comfort before finally giving it up. To those who sit beside the dead, this transition is often one of the most noticeable. The skin that once felt soft and warm becomes cooler to the touch, more still. Yet even then, it is not jarring, it is not frightening, it is simply the absence of motion. The body is not cold in an instant. It eases into stillness, into quiet, into the natural temperature of the world around it. In this way, the body at death becomes more like its surroundings. It no longer resists the cold or generates warmth. It joins the environment in silence and softness. The cooling is not a punishment. It is a return. A reminder that, in the end, we belong to the same air, the same soil, the same space we came from, and in cooling, we come home. When we speak about death today, especially in medical settings, One of the most important and complex ideas is brain death. It is often misunderstood and even more often surrounded by quiet uncertainty. To most people, the heart stopping feels like the end, but science now tells us that the true final border between life and death might live higher, behind the forehead, deep inside the folds of the brain. Brain death is not a coma, it is not sleep. It is the complete and irreversible loss of all activity in the brain, including the brainstem. The brainstem is what keeps the body breathing and the heart beating. It is where reflexes like blinking or swallowing begin. When this part of the brain stops working, there is no more connection between body and mind, no more breath without machines, no more signals traveling from thought to movement. In every meaningful way, the person is gone, even if the body still appears to rest peacefully. This distinction matters because in modern hospitals, with the help of machines, the body can be kept warm and breathing long after the brain has gone quiet. Ventilators can move air in and out. The heart may keep beating for a time, receiving oxygen from machines and signals from remaining cells. To someone standing nearby, the chest may rise and fall, the skin may stay soft and pink. But none of this means the person is still there. Without a working brain, there is no awareness, no pain, no memory, no self. Doctors use a number of tests to determine brain death, and they do not make that diagnosis lightly. They check for brainstem reflexes. They look for movement, response to pain, reaction to light or sound. They often perform something called an apnea test, where the ventilator is briefly paused to see if the brain attempts to take a breath on its own. If it does not, and if other signs are absent, the brain is considered to have fully stopped. Brain death is recognized in medicine and law as true death, even if machines continue to hum. This idea may seem strange at first, because the body can linger, but perhaps it makes sense when you consider how much of who we are lives in the brain. Our thoughts, our dreams, our voices, our sense of time. The brain does not simply coordinate the body, it houses our memories and our personalities. It is where joy and fear and love take shape. When it stops, we are no longer truly here. Still, the stillness of brain death is not violent. There is no pain. There is no awareness of the loss. It is a gentle silence, a fading of light behind the eyes. Like a candle burning down to the last flicker, it ends with peace. And though the body may linger for a while longer, the person has already drifted beyond. In that way, brain death is not an ending with edges, but a soft final chapter, one that closes without noise, one that leaves only quiet. For most of us, death feels like a firm boundary. Once the heart stops and the breath is gone, that seems to be the end. But nature, and the science that studies it, often works in softer lines. There are stories and studies that suggest death is not always as immediate as we once believed. In some rare and fascinating cases, people have returned from death after several minutes, even hours. These moments do not break the rules of biology. Instead, they reveal that biology's rules are more flexible than they seem. The body can sometimes survive in silence, especially under very specific conditions. Cold, for instance, changes everything. Hypothermia slows the body's functions to a crawl. When the body's temperature drops far enough, metabolism quiets, brain activity decreases, and oxygen needs shrink. In these cases, the heart might stop, breathing might cease, and yet the cells hold on. There is a window, fragile and short, where rewarming and medical care can bring someone back. It is not common, but it happens. A skier pulled from icy water, a child found in a snowbank, a swimmer rescued from a frozen lake. Their bodies appear lifeless, but they are not beyond reach. Modern medicine has learned to follow this lead. In certain surgeries, doctors now intentionally cool the body to protect the brain and organs during long or risky procedures. In a state of deep cooling, known as therapeutic hypothermia, the body enters a kind of pause. If the heart stops during this time, there may still be a chance to bring it back. In these moments, time stretches. Death becomes more like a doorway than a wall. There are also stories that fall more on the edge. People who were declared dead but later revived through chest compressions, defibrillation, or medication. In these moments, the heart may have been still, but not for long enough to damage the brain or other vital systems. Again, these are not miracles. They are the outer edges of science. The farthest reaches of what the human body can withstand. One of the most famous cases involves a woman who was submerged in icy water for over an hour. Her body temperature dropped to extreme lows. Her heart was not beating, and yet, with careful warming and medical intervention, she came back. Not only did she survive, but she made a full recovery. Stories like hers remind us that the body, especially under unusual conditions, is capable of astonishing resilience. These rare returns from death do not mean that death is reversible. Most of the time, once the heart and brain have stopped for long enough, there is no going back. But in those few cases where people do return, we are reminded of something strange and beautiful. Death is not always a single moment. It can be a process, with shadows and pauses, and sometimes an unexpected breath after silence. And in that breath, life begins again, quietly, gently, just as it once did the first time. Not every part of the body fades at the same pace. After death, while the heart has stopped and the breath has left, many organs still remain in a state of quiet waiting. They do not immediately surrender. Some, like the liver and kidneys, can survive for hours under the right conditions. Others, like the heart or lungs, are more fragile but can still function if given a second chance soon enough. This resilience is the foundation of something both scientific and profoundly human: organ donation. Inside each of us is a collection of systems that can carry on, if gently, preserved, even after we have let go. These organs are made of living cells, and those cells do not immediately know that death has occurred. They need time to understand. They need time to fall silent. Until then, they remain usable, transplantable, and filled with potential. In this short window, they can be removed and given to someone else, someone waiting in a hospital bed, someone whose own body is running out of time. This practice has become a deeply important part of modern medicine. When someone is declared brain dead, for example, their organs may still be supported by machines. The body is no longer conscious, but the heart still beats, blood still flows. The organs are warm and nourished. In this state, surgeons can recover organs for transplant with great care. It is a delicate process, done with respect, urgency, and precision. Timing is everything. Different organs follow different clocks. The heart and lungs must be transplanted within just a few hours. The liver and pancreas offer a bit more time. Kidneys are more forgiving still, often lasting longer than 12 hours if properly cooled. Even corneas and skin can be donated, offering sight or healing long after other systems have stilled. Each organ has its own rhythm, its own moment of parting. This quiet durability is not just a biological fact. It is a kind of hope. For those who have lost someone, it can be comforting to know that part of their loved one will go on. Not metaphorically, but truly. A liver will filter blood again. A heart will beat in a stranger's chest. Lungs will rise and fall. These are not symbols. They are real, physical continuations of life. For those who receive them, donated organs are more than medical tools. They are gifts wrapped in time, a second chance, a new beginning that comes from an ending. And while this exchange is rooted in science, It often feels spiritual, the idea that one body, just after death, can reach out and save another, quietly, generously, with no words, no ceremony, just function. The body is not just a vessel, it is a source. Even in its stillness, it has work to do. And through the science of transplantation, death does not close the story entirely. It hands the pen to someone else. A different life, a different rhythm, but a continuation nonetheless. There are stories people tell when they come close to death. Stories of tunnels filled with light, of rising above their bodies and watching doctors work below, of hearing voices, seeing loved ones long gone, or floating through places that feel both familiar and impossible. These are near-death experiences, and they have been reported by people across cultures, religions, and time periods. They are often described with the same gentle features: peace, clarity, detachment from pain. For many, they feel more real than waking life. And for scientists, they are a window into something both mysterious and deeply human. At first glance, near-death experiences might seem like evidence of something beyond biology. A glimpse into the afterlife, perhaps, but researchers have been studying them for decades, and what they've found suggests that the brain itself may play a central role. When the heart stops and oxygen supply is cut off, the brain begins to shut down, but before it does, it sometimes flares with activity. Some studies have recorded brief bursts of highly organized electrical patterns just after cardiac arrest, especially in areas linked to perception, memory, and emotion. This last wave of activity could create vivid experiences. The brain, deprived of oxygen, releases chemicals that can alter consciousness. Endorphins flood the system, which may explain the common sense of peace. Dopamine and serotonin may also rise, creating feelings of love, comfort, or euphoria. These chemicals, combined with the brain's natural tendency to make meaning from patterns, could lead to complex, emotionally rich visions. But the explanation is not so simple. Not everyone who comes close to death has these experiences, and some people report them in moments when the brain should be too damaged to create anything at all. Others have detailed events in the room that they should not have been able to perceive, including conversations or movements that happened while they were unconscious. These cases are rare, but they keep the door open to mystery. What makes near-death experiences so compelling is their consistency. People from different parts of the world, with no shared language or background, describe similar sensations: a feeling of being drawn towards something, a review of one's life, a sense of profound connection. Some describe crossing a boundary and choosing to return. Others say they were sent back. Whatever the details, the emotions are often the same: calm, warmth, a strange and beautiful stillness. From a scientific point of view, near-death experiences remain difficult to study. They are unpredictable, deeply personal, and often hard to capture in controlled settings. But that does not make them any less real to the people who experience them. Whether they come from brain chemistry or something beyond, they leave a lasting impression. Many who return from them describe less fear of death, more appreciation for life, a deeper sense of connection to others. Perhaps, in the end, that is what matters most. Not what causes these experiences, but what they give. A sense that the boundary between life and death may be softer than we think. A quiet reassurance, carried back from the edge, like a feather drifting down from a place just out of reach. Inside your body, death is always happening. Not the kind that takes a life, but the kind that keeps life going. Every second, millions of cells complete their purpose and quietly let themselves go. This process is known as programmed cell death, or apoptosis. It is not an accident, not a failure, but a design, a gentle self-removal that allows the body to grow, heal, and maintain balance. Without it, life would be chaotic. Too many cells, too many signals, too many parts clinging on long after they are needed. During your early development, apoptosis shaped your hands by removing the thin webbing between your fingers. It carved out your eyes and shaped your organs. It continues now in your immune system, making sure that damaged or unnecessary cells do not stay and cause harm. It works in your gut, where cells are constantly renewed. It even plays a role in preventing cancer by helping remove cells that behave badly. Apoptosis is the body's way of tidying up, like sweeping a floor or trimming a tree, small removals that prevent larger problems. When we die, this natural process does not suddenly stop. It expands. The signals that once told cells when to live and when to go begin to change. In the absence of coordination from the brain and heart, cells begin to follow the paths they know. Some continue dividing briefly, others begin their programmed exit. The difference is that now, the cleanup crew has also gone silent. The systems that normally contain and recycle these dying cells are no longer functioning. So instead of being quietly absorbed, the remains of these cells begin to break down and mix with their surroundings. This is where the transition begins. From organized, tidy endings to the slow, more visible process of decomposition. But for a time, the two exist side by side. The body does not rush toward decay. It moves through these steps like a careful dance. Apoptosis leads. It sets the rhythm. The cells that have been following its signals for a lifetime continue to do so, even as the larger systems fade. Scientists have studied this phenomenon not only to understand death, but to better understand life. The more we learn about how cells choose to die, the more we understand how diseases work. Some illnesses involve too much cell death, like neurodegenerative diseases. Others involve too little, like cancer. Studying apoptosis helps us understand how balance is maintained and what happens when it is lost. It is strange to think that death, on a small scale, is necessary for life. But that is the truth within each of us. Life depends on letting go, on releasing what is no longer needed. And when the body as a whole begins its final rest, the same principle holds. There is no panic, no rush, just a continuation of what the cells have always done. A quiet decision made in 1,000 places at once to stop holding on, to make space for what comes next. In the natural world, death seems universal. Everything alive must one day come to an end. And yet, scattered across the tapestry of life, there are strange exceptions. Creatures that do not seem to age in the same way we do. Organisms that repair themselves endlessly or avoid the usual signs of decline. These examples do not break the rules of biology, but they do suggest that the rules may be more flexible than we once thought. They give us a glimpse into something that has fascinated humans for centuries. The dream of immortality. There is a species of jellyfish, Turritopsis dohrnii, often referred to as the immortal jellyfish. Under certain conditions, when it is injured or stressed, it can revert its cells to an earlier stage of life. It does not just heal, it becomes young again. This process can happen repeatedly, allowing the jellyfish to cycle through its life over and over, like a biological loop with no final page. It does not live forever in the way a story lives forever, but in the way a song might start over each time it ends. Then there are the tardigrades, tiny water-dwelling creatures, also known as water bears. They can survive in extreme heat, cold, pressure, and even the vacuum of space. When conditions become too harsh, they dry themselves out and wait, sometimes for years. When the environment improves, they rehydrate and begin again, as if no time had passed. They are not truly immortal, but they stretch the limits of what survival can mean. Even in the plant world, there are trees that seem to defy time. Some clonal colonies, where one root system supports many stems, have survived for tens of thousands of years. They are not eternal, but their continuity is remarkable. They teach us that life, when connected and resilient, can persist through conditions that would break most other things. Humans, of course, are different. Our bodies wear down. Our cells lose the ability to divide cleanly. Damage accumulates. Telomeres, the little caps at the ends of our chromosomes, shorten with every cell division. Eventually, the machinery of the body becomes less precise. Aging, at its core, is the story of the body remembering how long it has been alive. Still, science is curious. Researchers study the genes of long-lived species. They explore ways to slow cellular aging, repair DNA, or even replace damaged tissues with lab-grown parts. These efforts do not aim for immortality in the fairy tale sense. They aim for longer life, healthier aging, and more time. Not eternal youth, but extended presence. The idea of living forever carries both fascination and unease. It is hard to imagine a life with no natural ending. Part of what gives life meaning is that it ends. Like a poem or a piece of music, it is shaped by its limits. Even the stars have lifespans. The dream of immortality may always shimmer at the edge of science, but in the quiet reality of biology, there is beauty in finitude. Life is precious not because it never ends, but because it does. In the wild, death is not an interruption. It is a part of the design. Animals do not fear it the way humans often do. They seem to understand it as something woven into the rhythm of the world. A quiet return, a necessary turning of the cycle. From the smallest insect to the largest whale, all creatures reach an end. And when they do, nature responds with a gentle kind of order. Some animals die, quickly and quietly, without ceremony. A bird falling from the sky, a deer resting beneath a tree. Others, like elephants, seem to recognize death in ways that feel deeply familiar. Elephants have been observed touching the bones of their fallen companions, pausing at sites where others have died, even carrying the remains for short distances. Scientists cannot say for sure what this behavior means, but it carries a sense of recognition, as if the animal knows that something has changed and stops to acknowledge it. Octopuses offer a stranger story. After mating, many species enter a period of rapid decline. The females guard their eggs without eating, and within weeks, their bodies begin to break down. Their muscles weaken, their skin dulls, and eventually, they die. This process is not caused by illness but by design. The same biological systems that guide life now guide its ending. In some species, special glands signal the brain to begin the process. It is not a failure, it is a pattern, a life complete. Insects show another version of this. Mayflies live as adults for only a single day, sometimes just a few hours. They rise from the water, dance in the air, mate, and fall. Their adult lives are so brief that they do not even eat. Their purpose is not to survive long, but to complete a single task. And when that task is done, they vanish like a spark in the wind. Among birds and mammals, some animals choose solitude as they near the end. It is not uncommon for an old cat or dog to wander away from home, seeking a quiet place to rest. Wolves and foxes have also been seen leaving their packs when they grow weak. This behavior, though not fully understood, suggests an instinct to find stillness alone, perhaps to protect the group, or perhaps to find peace. Predators and prey alike play roles in the cycle. When one animal dies, others benefit. Vultures, beetles, fungi, and bacteria all move in, not as destroyers, but as recyclers. In the forest, a fallen body becomes part of the soil. In the sea, it feeds entire communities on the ocean floor. Death, in this way, is generous. It feeds life. In nature, there is no pause between the last breath and the next beginning. The handoff is smooth, almost invisible. Death is not cruel or chaotic. It is balanced. It is efficient. It makes room. And in its quiet, the living go on, carrying traces of what came before. Nothing is wasted. Everything returns. And the story always continues. In the sky above, far beyond the reach of wind or weather, stars are living lives of their own. Though we often think of stars as permanent, fixed lights in the night, they too have lifespans. They are born, they grow, and eventually they die. These deaths are not quiet in the way human deaths are. They are vast, radiant, and in some cases unimaginably powerful. Yet even in the cosmic scale, the end of a star is not simply an ending, it is a beginning for something else. A star spends most of its life turning hydrogen into helium. This process releases energy, which pushes outward and balances the inward pull of gravity. As long as this balance holds, the star shines steadily. But eventually, the fuel begins to run low. The core starts to contract. The outer layers swell. A star like our Sun will become a red giant, growing large enough to engulf nearby planets. Then, with its core no longer able to sustain fusion, it will shed its outer layers into space. What remains is a white dwarf, a small, dense ember glowing in the darkness. Larger stars die more dramatically. When a massive star runs out of fuel, its core collapses in a fraction of a second. The outer layers fall inward and then explode outward in a supernova. This is one of the most energetic events in the universe. A single supernova can outshine an entire galaxy for a brief moment. The explosion spreads heavy elements into space, elements that could never have formed inside smaller stars. Gold, silver, uranium, and many others are forged in these final seconds. The dust and ash from a supernova drifts through space, sometimes joining clouds of gas that one day will form new stars and planets. If the star is even more massive, the collapse continues past the white dwarf stage, past the neutron star stage, into something even stranger, a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. These objects are not easy to understand, but they are real, and they are formed through the final breath of the universe's most powerful stars. The death of a star is not only dramatic, it is necessary. Without these endings, the universe would be filled with light, but not life. The carbon in your body, the calcium in your bones, the iron in your blood, all of it was born in stars. Some from smaller stars like our Sunday, some from ancient supernovae that scattered their contents across space long before Earth was formed. When you look at the night sky and see a faint glimmer, you are looking at something both old and temporary. Some of the stars you see may already be gone, their light only now reaching you after traveling for hundreds or thousands of years. Their deaths were not ends, but transformations. They gave the universe its beauty, its chemistry, and ultimately its chance at life. Even in collapse, a star gives. Even in darkness, it shapes what comes next. If you have ever watched ice melt or seen a cup of hot tea grow cold, you have witnessed a law of the universe quietly at work. It is called entropy. It is the tendency of things to move from order to disorder, from structure to softness, from something precise to something scattered. Entropy is not chaos. It is not destruction. It is a gentle drift toward equilibrium. It governs everything, from the cooling of a stone to the fading of stars. and in the long run, it tells the story of how the universe itself might someday die. In the early moments of the cosmos, things were tightly packed, dense, and unimaginably hot. Over time, everything expanded and cooled. Galaxies formed, stars lit up, planets settled into motion. Life arose, clinging to small pockets of complexity. But through it all, entropy never stopped. It continued, slowly spreading energy out more evenly. It is not that energy disappears. It simply becomes less useful, less able to do work, more spread out and diluted. A flashlight beam in fog, a drop of dye in water. In the distant future, this process will continue. Stars will burn through their fuel and go dark. Galaxies will drift apart. Black holes will consume what they can, then evaporate over vast stretches of time. The universe will not end in fire, but in a slow and silent cooling, a long sigh, a fading of contrast, a final night. This vision is sometimes called the heat death of the universe. Though the term can be misleading, it does not mean everything becomes hot. It means there will be no more usable heat, no more gradients, no more movement from one place to another. Everything will have spread so evenly that nothing will happen. No sparks, no storms, no stories. Still, this end is so far away that it exists more as a thought than a threat. The numbers are almost too large to say aloud. Trillions of years, followed by more trillions. It is not something we will see. It is a concept that reminds us how all things, even the universe itself, are subject to change. And yet, within this truth lies something oddly comforting. Entropy gives us time. It gives us sunsets and autumn leaves. It gives us the warmth of firelight and the slow aging of trees. Without it, nothing would change, and without change, there could be no life. Entropy does not rush. It does not force. It simply waits, moving everything gently toward balance. Some have described the universe as a grand clock slowly winding down, but perhaps it is more like a candle, one that burns with quiet light for as long as it can, and when it fades, it leaves behind warmth, shadows, and space for memory. Entropy is not the enemy of life. It is the background against which life becomes visible. It is the contrast that lets us see what matters. It is the soft reminder that everything beautiful exists because it will not last forever. Of all the questions we ask about death, the one that lingers most softly, yet most persistently, is what happens to consciousness. That quiet awareness we carry from moment to moment, the sense of self, the stream of thoughts that feels like us, moving quietly behind our eyes. It is not something we can touch or measure directly. It is not tied to any single part of the body. And yet, it defines our experience of being alive. Science has explored this mystery with great care, but the answers remain gentle and incomplete. We know that consciousness arises from the brain, not from one region, but from the way different parts communicate. The thalamus, the cortex, the brainstem. Together, they create the spark. It is not a switch that flips on. It is a pattern, a network, a rhythm of activity that makes the world feel present and the self feel separate. When the brain is injured, that rhythm can falter. In deep sleep, under anesthesia, or during a coma, consciousness dims. In some cases, it disappears entirely, then returns without memory. These states help us understand what consciousness is not. It is not permanent, it is not immune to change, and it is not easily preserved without the full function of the brain. When the body dies, and the brain no longer receives blood or oxygen, consciousness fades, quickly at first, then more slowly. Within seconds, the signals break down. Within minutes, the delicate balance that keeps awareness alive is gone. Scientists believe this is the end, that consciousness, like a flame, requires the right conditions to continue, and when those conditions vanish, so too does the light. But this understanding does not mean the experience is harsh. If anything, it suggests a soft fading, a gentle unwinding of thought and sensation, like slipping into sleep without realizing it. There is no evidence of pain or fear in those final seconds. In fact, the chemical waves that move through the brain may bring calm. Endorphins rise, neural networks go quiet, the self loosens and disappears. Still, questions remain. Some people who have come close to death report vivid experiences, a sense of floating, a vision of light, a feeling of clarity or unity. These may be the brain's final activity, shaped by memory and imagination, or they may point to something deeper, something we do not yet understand. Science does not dismiss these experiences. It simply holds them with care, knowing that not everything can be measured. In the end, what we call consciousness may be the most delicate part of us. A fragile structure held together by biology, yet filled with poetry. It connects us to others. It helps us love, remember, create, and when it leaves, it does so quietly, without a trace, but not without meaning. Whether it ends entirely or moves into something else is not a question science can fully answer. But what is clear is that consciousness, however brief, is a gift. A light that flickers in the dark, makes sense of the world, and then gently lets it go. When we think of nothing, we often imagine emptiness, a blank space, silence, stillness. But in the world of physics, nothing is rarely so simple. In fact, it is never truly nothing at all. The more closely scientists look at what appears to be empty space, the more they find it humming with quiet activity. Even the vacuum, that deep and dark backdrop of the universe, is not silent. It flickers. It stirs. It dreams. A vacuum is not just the absence of matter. It is the absence of particles, of atoms, of all the things we see and touch. But underneath that absence, there is structure. The vacuum contains fields, like the electromagnetic field or the Higgs field, and these fields are never entirely still. They fluctuate. Tiny particles can appear for the briefest moment, exist for a fraction of a second, and then vanish again. This is not science fiction. It is a real and measurable part of quantum physics. These are called virtual particles, and they come from what is known as quantum vacuum fluctuations. Imagine a pond on a windless day. The surface looks calm, almost frozen, but if you could zoom in far enough, you would see tiny ripples, motion too small for the eye to catch. The vacuum is like that, calm from a distance, restless when viewed closely. These fluctuations are part of what makes the universe dynamic. They are not caused by anything. They are a feature of existence itself. In some experiments, scientists have even seen the effects of these ripples. The Casimir effect, for example, shows that two uncharged plates placed very close together in a vacuum will feel a force pulling them together, not because of gravity or magnetism, but because of the pressure of quantum fields in the empty space between them. Nothing, it turns out, has weight. This strange and subtle activity may even play a role in the expansion of the universe. Some theories suggest that dark energy, the mysterious force causing galaxies to drift apart faster and faster, could be linked to the energy of empty space. That would mean the very fabric of nothingness holds enough power to shape the fate of everything. When we think of death, we sometimes picture nothingness, a great silent void. But perhaps this picture needs softening. If the universe cannot be truly empty, then maybe the end is not truly empty either. Maybe what we call nothing is simply a different kind of something. A space where things move in ways we do not yet understand. A place where silence is full of possibility. This idea is not meant to offer answers, but wonder. The kind that invites us to see death not as a sharp edge, but as a threshold. Not an absence, but a change in form. In physics, nothing is never truly nothing. And perhaps, in the quiet end of life, there is more still happening than we can see. Something quiet, something gentle, something waiting. To imagine death in space is to imagine silence on a scale beyond anything we know. There is no wind among the stars, no sound carried through the vacuum, no rustle of leaves or hum of machines. Just the great quiet, stretching in all directions, and yet death still has a place there. It follows the same rules, shaped by biology and physics, though the stage is vastly different. In the vacuum of space, the human body would not behave as it does on Earth. Without atmospheric pressure, gases inside the body would begin to expand. The skin, surprisingly strong, would hold everything in, but there would be swelling. There would be no explosive decompression. That idea, popular in stories, does not reflect the slow truth. A person exposed to open space would lose consciousness within seconds, not because of cold or pressure, but because of the lack of oxygen. The brain cannot go long without it. After unconsciousness, death would follow quickly. The body would not float forever alive, but it would remain, untouched by decay in the usual sense. Without bacteria, without moisture, without warmth, the process of decomposition would pause. In orbit around a planet or adrift in deep space, the body could remain almost unchanged for a very long time. It would slowly dry out, frozen by the cold, shielded from the elements that normally break things down. If a body were left near a planet or moon without an atmosphere, the story would be similar. No wind to carry scent, no soil to accept the remains, just the sun, unfiltered, sending its radiation across the skin. Over time, the body would become damaged by that radiation. The skin might bleach, the tissue might become brittle, but the process would be slow, stretched over years or centuries. Inside a spacecraft, things would be different. If life support failed and someone died aboard, the body would stay in a stable environment for a time. Without proper refrigeration or preservation, decay would begin slowly. Some microbes would still be active. Over time, gases would build. In a closed system, this creates challenges, but scientists have already thought about these possibilities. Space agencies have studied how to respectfully and safely store remains on long missions. Someday, as humans travel farther from Earth, these questions will become more pressing. There is something quietly haunting about death in space. It is not tragic by itself. It is peaceful, in a way. Free from sound, free from weather, free from the rush of gravity. A body in orbit might circle a planet for thousands of years, long after the spacecraft it came from has gone silent. It becomes a kind of monument, a marker not of failure, but of presence, a sign that someone once walked among the stars. And though the body cannot speak, it tells a story of courage, of exploration, of the strange and beautiful limits of life. Death in space is not an erasure, it is a stillness carried by light, a quiet drift through the oldest silence, their island. When a body is returned to the earth, something gentle begins. Burial is not just a tradition or a ritual, it is also a biological process, shaped by soil, air, moisture, and time. The ground becomes a kind of host, receiving what has been given back to it, and in this quiet exchange, transformation begins. The soil is not empty. It is filled with life, from the tiniest bacteria to the slow, stretching roots of trees. These living things are always searching for nutrients, always responding to what the earth holds. When a body is buried, it becomes part of that system. Slowly, layer by layer, the body begins to change. Cells break down, tissues soften, microbes move in. Fungi thread their way through, delicate and patient. This is not destruction, it is nourishment. The same elements that made a human body strong and warm and thinking now return to feed the world. Carbon, nitrogen, phosphorus, calcium. These are not lost, they are passed on. A tree nearby may send out roots that draw water and minerals from the soil, minerals that once lived inside a person. Leaves grow, flowers bloom, insects crawl through the ground above. Life continues, shaped by what was left behind. The pace of this process depends on many things: the type of soil, the depth of the grave, the presence of air or water. In some places, decomposition moves quickly. In others, it takes years. Dry soil slows the change, wet soil speeds it up. Cold preserves, warmth welcomes activity. But no matter the pace, the direction is the same: toward return, toward renewal. Green burials, which avoid embalming fluids and heavy caskets, are designed to let this process unfold naturally. The body is placed in a biodegradable container, or sometimes directly in the earth, wrapped in cloth. Nothing blocks the connection to the soil. This allows microbes, insects, and plants to begin their work sooner. It is a softer approach, meant to honor the body as part of the land rather than as something to be hidden from it. Even traditional burials, though slower, lead eventually to the same result. The body, protected and delayed, still finds its way back. Stone and root and time are patient. They do not rush. They wait, and in that waiting, they welcome. Fungi play a special role in this return. Some species form networks that connect trees to one another, moving nutrients between them. These mycelial threads can link vast areas of forest, creating what some call the wood wide web. When a body enters the soil, fungi can help transfer its elements into this living network. The forest does not forget what it is given, it uses it, it grows with it. To be buried is to be gathered, not lost but held, not erased but shared. The biology of burial is not grim, it is generous. It is the last act of giving, the final release of everything the body once carried, and in return, the earth gives back green and bloom and breath. In the past, when someone died, their voice was gone. Their image might linger in a photograph or their words in a letter, but the presence itself faded into memory. Now, in the age of the internet and digital storage, the echoes stretch farther. A person's photos, messages, videos, and online thoughts often remain long after their body has gone. These digital traces form something new, a kind of shadow self that stays behind, stored in clouds and servers, glowing quietly on screens around the world. This presence can feel comforting. A favorite voicemail played again and again, a message reread in the quiet hours of night, a video where the face smiles, the laugh still rings. These fragments offer warmth, they offer continuity. They let people grieve with connection rather than absence. The digital self lingers, not alive, not conscious, but still speaking in a way that feels real. Some companies have even begun to explore ways of making this digital afterlife more interactive. Using artificial intelligence trained on a person's messages, voice recordings, and writing style, they attempt to build simulations, chatbots that respond like the person once did, voice assistants that speak in familiar tones, even virtual avatars that mimic facial expressions. These technologies are still early, but they raise soft and complex questions. What does it mean to stay, not in body or soul, but in data? For some, this idea feels hopeful, a chance to preserve a part of someone too beautiful to lose completely. For others, it feels strange. A copy that speaks without understanding, a performance without presence. These responses vary, and perhaps they should. Grief is personal. Memory is layered. What brings peace to one may bring discomfort to another. What is clear is that our relationship with death is changing. The border between life and absence is no longer as sharp. A person may be gone, and yet their playlists update. Their name appears in messages from years ago. Social media pages continue to gather comments, tributes, birthday wishes. The line between past and present becomes thinner. Even more gently, there are those who plan their digital afterlives while still living, writing messages to be sent after they are gone. Curating photo albums, organizing journals, choosing how they will be remembered in pixels and code. It is a kind of storytelling, a soft handing over of the narrative. But no matter how detailed these digital reflections become, they are not replacements. They cannot feel or change or wonder. They are not the person. They are only what remains, a still frame. A recorded laugh, a quiet mirror that holds what once was, and nothing more. And perhaps that is enough, to leave behind not just bones and breath, but stories, a face in the glow of a screen, a sentence that arrives at just the right time, a presence that flickers gently in the silence. The digital afterlife is not eternal, but it is something, a shimmer, a voice carried forward, a light that keeps shining just a little longer in the dark. When we picture death, we often imagine it as stillness, a body unmoving, a quiet room, a sudden absence. But beneath that quiet, something intricate is unfolding. Death is not disorder. It is not chaos. It is a series of changes that follow a remarkably steady path. The patterns of the end are not wild. They are delicate, repeating, almost elegant in their order. From the first moment the heart stops, the body begins to respond. Blood, no longer pushed through vessels, begins to settle. Gravity pulls it gently downward. This creates soft shading in the skin, known as livor mortis. The areas closest to the ground darken slightly, while the upper parts remain lighter. It is a slow, graceful transition, like the sun casting shadows at the end of the day. Then, the muscles begin to stiffen. This is called rigor mortis, and it usually starts within a few hours. The smallest muscles stiffen first, the eyelids, the jaw, then the arms and legs follow. For a time, the body holds this firmness, as though pausing in place, but it does not last. After a day or so, the muscles soften again. The body releases its grip. Everything loosens, the way a hand slowly opens in sleep. Temperature follows its own path. As the body cools, it moves toward the temperature of the surrounding air. This cooling is steady, predictable. It can even be measured to help estimate the time of death. There is no rush, no sudden drop, just a quiet surrender of warmth, 1 degree at a time. Even on a cellular level, the changes follow patterns. Without oxygen, cells switch from efficient energy production to slower, more chaotic methods. Acids begin to build, membranes weaken. Enzymes leak and start to break down structures from within. But this does not happen all at once. Different cells respond at different speeds. Some last longer than others. The body does not fall apart. It lets go in sections. Fungi, bacteria, and insects join in eventually, each following their own rhythm. Certain species appear in a set order, drawn by the changing chemistry of the body. Entomologists can often estimate how long a body has been still based on which insects are present. It is a quiet clock, ticking forward with tiny wings and thread-like roots. From the outside, death may appear sudden, but from within, it is more like a tide going out, a gradual retreat, a passing through soft, familiar stages. There is nothing frantic in it. No confusion, just the body completing its last instructions, one after another as it always has. In this, there is something unexpectedly peaceful. Death is not a breaking. It is a final movement in a lifelong sequence, the last act of biology performing what it knows how to do. The end is not messy, it is measured, it is steady, it is patient. Like a song reaching its final note, held for just a moment longer before silence. To think about death is not to turn away from life. It is to look more closely at what makes each moment so quietly important. When we remember that life ends, something in us softens. The urgency falls away. The little worries lose their edge. And what remains is the gentle clarity of now, the warmth of a voice, the way sunlight moves across a table, the feel of breath rising and falling without effort. These things become brighter when we understand they are not forever. In many cultures, the awareness of death is not hidden. It is welcomed as a teacher. Monks meditate beside bones. Poets write of falling leaves. Artists paint time as a soft river, always moving. This is not about sadness. It is about attention. When we know something will not last, we hold it more dearly. A single flower, a shared meal, the sound of rain on the roof, the science of death with all its calm and careful observations does not diminish the mystery. If anything, it deepens it. To know how the heart slows, how the brain fades, how the body returns to the earth, is to see death as part of the pattern, a closing of the circle. It is not something that breaks us. It is something that completes us. Life without death would be flat, without shape, without contrast. It is the finiteness that gives it color. Even stars die, even mountains crumble. But in their ending, they give something back. The death of a star seeds the galaxy with gold. The erosion of stone feeds the roots of trees. The quiet falling apart of things is what makes room for the next beginning. We are part of this same pattern, born of stardust, carried by time, returned to silence. Some people say that thinking about death makes them anxious, that it brings fear, but many find the opposite. They find peace in the truth that nothing must be permanent to be meaningful. That love matters not because it lasts forever, but because it happens at all. That memories shine not because they never fade, but because they once were real. When you remember that your days are numbered, you begin to count them not with dread, but with gratitude. You take walks more slowly, you listen more deeply, you speak with more care. The beauty of death is not in the ending, it is in how it shapes the middle. So as you close your eyes tonight and let the world grow quiet, let this thought rest beside you. That your life, with all its twists and tenderness, is precious because it is brief. That your breath is a rhythm shared with stars and trees. That your presence here is a soft miracle, made all the softer because it cannot stay. In knowing it ends, we begin to see just how brightly it glows. Life is sweet not in spite of death, but because of it. And that sweetness, even as it fades, stays with us, quietly, gently, always. So, as you drift off, as your thoughts grow quiet and your body begins its own nightly stillness, remember this: death, in all its mystery, is not chaos. It's not a monster lurking in the dark. It's a slow unwinding, a returning, a becoming something else. Whether it's the soft fading of cells, the quiet blooming of stars into dust, or the gentle hush of a final breath, every version of death we know is patterned, peaceful, and in many ways, full of meaning. Even in endings, there is elegance. In stillness, there is transformation. In letting go, there is continuation. So sleep well tonight, dear thinker. Let your body rest and your breath deepen, because even if the universe fades someday, even if entropy wins in the end, right now, you are here. You are warm. You are stardust, thinking about stardust. And that, in itself, is something quietly extraordinary. Sweet dreams, and may your thoughts drift gently, like dandelion seeds on a soft breeze into the dark, and the deep, and the beautiful unknown.